Hello friend, in this video I will discuss a numerical problem related to game theory, and this is most popular question that was frequently asked for IGNOU MA Economics first year for course code MEC 101. Title is Microeconomics Analysis, carried 12 marks. And this question you can see first have description of this game table. You can see there are two players in this game, player number 1, player number 2. Player number 1 has 3 strategy: rock, paper, scissors, whereas player 2 has also 3 strategy. You can see rock, paper, scissors, and you are also seeing boxes. There are 9 boxes you can see in this game table, and there are 2 digits in each box, and first digit in each box representing payoff to player 1, and whereas second digit in each box representing payoff to player 2. Now before moving ahead on the solution of this game theory numerical problem, if you come first time at my channel, please subscribe my channel and hit bell icon for all notifications so that you can get my latest video notification easily. Now let us start solution. Suppose player number 1 play a strategy rock with probability P1, paper with probability P2, and player 1 plays a strategy of scissors with the probability 1 minus P1 minus P2, because since sum of probability is equal to 1, and here we are subtracting sum of probability of P1 plus P2, and it can be written 1 minus P1 minus P2, and player 1 plays scissors with the probability 1 minus P1 minus P2. Similarly, player 2, assuming he plays rock a strategy with the probability Q1, plays a strategy paper with probability Q2, and finally plays scissors with probability 1 minus Q1 minus Q2. Now we need to focus one by one. First focus on player number 1. For player 1, now player 1 has a 3 strategy. You can see rock, paper, scissors. Now we get expected value of rock strategy, okay, R, rock. Okay, the first digit in each box implying payoff going to player 1. You can see I am marking with red color, and second digit, you know, it is the payoff going to player 2. Now what is the value of expected value of a strategy R? First digit 0 into Q1, because with the given player 2 strategy, player 1 play this game. Minus plus minus 1 into Q2 plus 1 into 1 minus Q1 minus Q2. Now solve it. 0 into Q1, 0, plus into minus, minus Q2, and if you multiply this bracket by 1, we get same result, 1 minus Q1 minus Q2. And solving this thing, minus first writing minus Q1 minus cube 2 minus cube 2, it become minus 2 cube 2 plus 1. Similarly, we can get expected value of paper. Here writing only P stand for paper expected value. Paper here 1 into Q1, 0 plus 0 into cube 2, minus 1 into 1 minus Q1 minus cube 2. Solve it. Q1 plus 0, and if multiply this bracket by minus 1, all sign become opposite. Okay, minus 1 plus Q1 plus Q2. Here Q1 it become 2 Q1 plus Q2 minus 1. And finally we need to calculate expected value of seizure. Expected value of seizure. Here S standing for seizure. Minus 1 into Q1, minus 1 into Q1, 1 into Q2 plus 0 into 1 minus Q1 cube 2. And here get minus Q1 plus cube 2. This entire term becomes 0 since it is a multiply by 0. It become minus Q1 plus cube 2. Now next task in this question to equate expected value of rock with expected value of seizure in order to eliminate, okay, which term? Q1, because Q1 you can write what value got for expected value of rock, minus Q1 minus 2 cube 2 plus 1 equal to minus Q1 plus cube 2, and shifting these two terms in LHS side, minus Q1 minus 2 cube 2 plus 1, it become plus Q1 minus cube 2 equal to 0. Now minus Q1 plus Q1 cancel, minus 2 cube 2 minus cube 2, it become minus 3 cube 2 equal plus 1 equal to 0. Shifting plus 1 in RHS side, it become minus 1. Minus 3 cube 2 equal to minus 1, minus minus cancel, cube 2 equal to 1 by 3. Now next task in this question to equate expected value of paper with expected value of seizure. Expected value of paper with expected value of seizure in order to eliminate cube 2 in this equation. Yes, by mistake 2q1 q2 minus 1 2q1 plus q2 minus 1 and expected value for seizure minus q1 plus q2. Shifting minus q1 plus q2 in LHS side, 2q1 plus q2 minus 1 plus q1 minus q2 equal to 0, minus q2 plus q2 cancel, 2q1 plus q1 it become 3q1 minus 1 equal to 0, 3q1 minus plus 1, and therefore q1 equal to 1 by 3. And when we get the value of q1 q2, it becomes so easy to get the value of 1 minus q1 q2. 1 minus 1 by 3, q1 equal to q2 equal to 1 by 3, and taking the LCM we get 3, 3 minus 2, 3 minus 1 minus 1, it become 3 minus 2 by 3, 1 by 3. Now we can write mix strategy q1 q2 1 minus q1 q2 mixed a strategy q1 q2 1 minus q1 minus q2 for player 2 because we assume at the starting of solution of this problem player 2 play game with a strategy q1 q2 1 minus q1 q2 respectively equal to 1 by 3. It is the value of q1 q2 1 by 3 1 minus q1 q2 we got value 1 by 3. Similarly we can get a strategy value of probability for player mixed strategy probability assigned for mixed strategy for player 1. This is the player 2. Now we need to focus on player 2 with the given player 1 strategy, player 2 play game. Now you can see player 2 has a 3 strategy and second number in each box representing payoff going to player 2. Player 2 for player 2 expected value of rock R equal to second digit 0 into P1 plus minus 1 into P2 and 1 into 1 minus P1 P2. Similar work I am doing as we did it for player 1. 0 minus P2 1 plus 1 minus P1 minus P2 and it become minus P1 writing first minus P2 it become minus 2 P2 plus 1. Expected value of paper here 1 into P1 plus 0 into P2 minus 1 into 1 minus P1 minus P2. Here P1 0 minus 1 plus P1 plus P2 and P1 2 P1 plus P2 minus 1. Similar work I am doing here as already done it for player 1. Now we need to calculate expected value of seizure minus 1 into P1 1 into P2 plus 0 into 1 minus P1 minus P2. It become minus P1 plus P2. If multiply by 0 it becomes 0. Now we get minus P1 plus P2. Next task in this question, similarly we need to equate expected value of rock with expected value of seizure in order to eliminate P1. Now what value we got for expected value of rock? You can see here minus P1 minus 2 P2 plus 1 equal to minus P1 plus P2, shifting minus P1 plus P2 in LHS side minus P1 minus 2 P2 plus 1 plus P1 minus P2 equal to 0. Plus minus P1 cancel, minus 2p2 minus p2, it become minus 3p2 plus 1 equal to 0, minus 3p2 equal to minus 1, minus minus cancel, p2 equal to 1 by 3. Next task, equating expected value of paper with expected value of seizure in order to eliminate p2. Okay, what value we got for expected value of paper? 2p1 plus p2 minus 1 equal to seizure. You can see here minus p1 plus p2, shifting minus p1 plus p2 in LHS side. 2p2 p1 plus p2 minus 1 plus p1 minus p2 equal to 0, minus p2 plus p2 cancel, 2p1 plus p1 it become 3, p1 minus 1 equal to 0, shifting minus 1 in RHS into RHS side, it become plus 1, and therefore p1 equal to 1 by 3. And when we got the value of p1 p2, it becomes so easy to calculate the value of 1 minus p1 minus p2. Substituting the value of p1 we got for 1 by 3, p2 we got here 1 by 3. Taking the LCM we get 3 in denominator, 3 minus 1 minus 1, 3 minus 2 by 3 equal to 1 by 3. Now mixed strategy, p1 p2 mixed strategy p1 p2 1 minus p1 p2. For player 1 equal to is 1 by 3 for p1, 1 by 3 p2, 1 minus p1 p2 equal to 1 by 3. It means player 1 play rock strategy with probability 1 by 3, paper strategy with probability 1 by 3, and seizure strategy with probability 1 by 3. This is the complete video on game theory, rock, paper, seizure, and it is a very most important and most repeated question. You can frequently it is frequently asked in IGNOU MA Economics for first year, first paper, MEC 101 Microeconomics Analysis. You can visit just previous year's IGNOU question. Large number of time it was asked. Thanks for watching my video till end. Jai Hind.